If you're looking to speedrun your career into a senior software engineering role and get that 35k job at Netflix, you'll need to learn how to unit test. And in today's video, we're going to be talking about what unit testing is, where does it fall on a testing pyramid, what a black box approach is, and how to write quality unit tests. A long time ago, software engineers got tired of manually testing their code and realized they can write more code, well, to actually test their code. And that is what essentially automation testing is. Unit testing is a method to test individual code or components for an application. It involves writing and executing tests for each unit of code in isolation, ensuring correct functionality. And the most famous example is having the sum function and making sure that it adds the numbers correctly, like this. This here is sum function, adds two numbers, and the test is expecting that the sum of 1 and 2 is 3. Here we go, run the test, we have our test passing. Now to secure that 500k job at Meta, you'll need to grasp the levels of automation testing. There are multiple models available of all the different levels of automation testing, and all of them put the emphasis on different level. For example, the trophy model puts the emphasis on the integration level of testing, and the pyramid model puts the unit testing as the foundation of the pyramid, making them the most important tests you need to write for your application. And all of them have their own separate arguments why those are the most important tests, but I'll leave that for another video. Black box testing is a method of software testing that examines the functionality of our application without peering into the internal structures or workings. What this basically means is each unit or each functionality you want to test is the black box, and you have input and output, and you don't really care what's inside the black box, hence the naming the black box. And in my opinion, this method is very good for unit testing because it allows you to test all the different scenarios against your unit without actually knowing what's inside, thus making sure that all the scenarios are covered. And also this method can be applied to every single level of automation testing, and sometimes it can be referred to as specification-based testing. Code coverage, a common unit testing measurement, quantifies how much of our code is covered by tests. And many teams out there have different levels of minimum coverage testing for their team. And some of the teams that I've been on usually go for 80%. While all test frameworks provide coverage data, it's not the definitive quality indicator of our tests. It simply reveals if every line, every if statement, every branch is covered by unit tests. For example, if we have some if-else statements in our sum functions before, checking that one of the numbers is 0 or the other one is 0, and when we run the tests, if our code doesn't actually go into these if statements, then those will be considered as not covered lines. And when you run your test with code coverage output, you'll see that those lines are uncovered. And also code coverage gives you 4 columns for different data. It gives you how many of the statements were executed, how many of the branches were executed, how many of the functions and how many of the lines were covered. Better unit tests are more about quality than just covering all the code. That is tricky though, because we can't really measure quality as we can with code coverage. So instead of focusing on 100% code coverage, think about the real life scenarios that your code will face and write tests for those situations. And another useful tip is to write a test for each bug you encounter and solve in your code. That way you know that whenever the code is changed in the future, that bug won't ever come back again. While researching for this video, I came across this pyramid of unit testing benefits. And this illustration really showcases which are the biggest benefits you're gonna experience from unit testing and against the time when you're gonna experience these benefits. Now let's go into this a little bit. At the foundation of the pyramid, we have validate your code changes. And what this means is whenever you're writing code and any code changes, you can write unit tests to make sure that those code changes are doing what it's expected of them, and you will benefit from this immediately as you write the unit tests. As we go up the pyramid, we have up-to-date documentation, and the benefit of this is not going to be immediate, but it's also not going to be a long time until you experience it. And the reason why this is here is your unit tests also serve as documentation. If someone wants to see how your function works and all the different scenarios around it, they can go to unit tests and see how the function is supposed to behave, how it's not supposed to behave, and all the different outputs for the different inputs. And at the top of the pyramid is refactoring safety net, and the time to experience this benefit is a longer time because you don't really refactor code that often, I guess. But the benefit of this is if you just want to go in and refactor the function, and that function already has all the unit tests required for it, you can just change the code and refactor it to make it better and run the unit test every time you make a change to make sure that the function still works as expected, and you don't need to update those unit tests because it's just refactoring code. Ideally, that's how it's supposed to work. Now, I think unit testing is very useful when working on a bigger team. For example, if I write a function and someone else uses my function in a different file that I don't even know where it is or how it's using it, if I have good unit tests, they can figure out the best way to use my function, and if I later go and add any changes to that function, I can see if that breaks anything else in the code, provided that they have unit tests for that. It basically bulletproofs you from unknown bugs or regression testing. There's also a lot of arguments out there that you don't need unit testing or they're not as important, but if you really just want to progress in your career, I think they're very useful to learn, even if you don't really use them as everyone else. I think if you look at all the job descriptions, they all have unit testing required. Most of the teams, especially the higher you go into career, most of them expect you to know how to unit test. And even if you don't really unit test for every different scenario, don't cover all your code, knowing how to unit test will help you think how your function can be tested in the future and making sure that the function works as expected. When I started writing code, I didn't write unit tests at all. I didn't even know what they were until like 3 years into my career. And the biggest benefit I have experienced from unit testing is making sure that I don't break something unexpected, like changing a small function that's being used in 100 different places. When I make the change, I don't have any assurances that those other 100 places still work as expected. And if they have unit tests, then I will have that assurance. And I've worked on a big code base before that didn't have any unit tests at all. You'll be surprised of the website that are using this code base, but there have been so many instances where we make a change, deploy, and we realize, oh, this actually broke something totally different and we didn't connect the dots until now. One of the bigger arguments about not writing unit tests is if you use TypeScript. For example, the sum function I showed before is expecting 2 numbers, but what if we send 2 strings, or what if we send 1 string and 1 number? Then the result is gonna be something unexpected. If you don't have type safety in your application, you need to validate that the input is what the function expects it to be. And then those will be the scenarios for unit tests. For example, how does the function behave when I send unexpected input? How does the function behave when I send different types? But if you're using TypeScript and you have strict type safety in your application, then all of those will go away, because whenever someone uses your function, when they send strings instead of a number, they'll get a message. And if you check all the types before deploying or whatever, you can see these errors and solve them without writing unit tests. And that's a great argument for not using unit tests. I think there's also a lot of different frameworks that make sure that your application runs as expected and you don't actually need to unit test and cover all of your code. But like I mentioned before, the quality of the unit tests is the most important thing here, and I'll leave it up to you to decide what's the best approach, what's the best methodology to follow, which pyramid or trophy you want to use. But hopefully this video showcases some of them, showcases some of the approaches to use when it comes to unit testing, why they're important. And yeah, that's been it for this video. I hope you liked it. I hope you learned something. If you have any thoughts, feel free to put them down in the comments. I reply to all my comments on all my videos. And yeah, that's been it. Enjoy the rest of your day. Happy coding. Bye.